So I'm going to talk about using Go for the past 2 years in production. And, all right. So I'm Travis Reeder, CTO and co-founder of Iron.io. We're the creators of IronMQ and Iron Worker. We basically have a platform for all your asynchronous and background processing. Check it out, www.iron.io. So first I'm going to talk about how we decided on Go, how we got to that point. So when we first started, we wrote Iron Worker as a consulting company to scratch our own itch with data processing. And the consulting company, we're doing Ruby on Rails, because if you're doing consulting a couple years ago, that was a pretty hot thing to do, and people paid you for it. So that's how it got built in the first place. So when we were running our API servers, most of this talk is going to be about the API servers for the high performance stuff. We would try to keep our server load at about 50% or less. There's a reason for that that I'll get to. When it increased beyond that, we'd launch more servers, and that's fine if you have a lot of money to spend. But being a startup, we didn't have a lot of money. This is how I thought Amazon looked at us. So the bigger problem wasn't really the money, it was actually the traffic spikes. When we had spikes in traffic on our APIs, a couple of the servers would spike up to 100% for no apparent reason. And when a server hits 100%, it becomes unresponsive. So when it's unresponsive, the load balancer takes it offline, spreads the load across the rest of the servers, which adds more load to those. So it's a domino effect. More load, more servers become unresponsive, more servers taken offline, so on until you're completely down. Servers going up and down off the load balancer. We like to refer to this as a colossal cluster F, another term, technical term. This is that phenomenon visualized. At the top is nice. One server goes down, the load's distributed to the other ones. Inevitably, more and more servers keep going down. So we had two options: either spend more money or rewrite it. And we decided to rewrite it. So choosing a language, we reviewed a bunch of different languages. We reviewed all the other dynamic languages, see if we could do something fast like Python, Node. We looked at Java and other derivatives. I come from a long Java background, so that was on the table, but I really didn't want to get into it. Then we looked at Go and ended up choosing it. And here's why. Concurrency being a fundamental part of the language was huge for us. There's other concurrency modules for Java and whatnot, like java.util.concurrency, but Go being so core was really nice. The core library had almost everything we need. We didn't need to depend too much on other libraries. I think we used maybe 2 other open source libraries. One was for a database driver, another one was for routing. It's terse language, like Sydney was saying, it sort of feels like a dynamic language. Compiles fast, runs fast, and it's fun to write in, sort of like Ruby. And Google is behind it. That was another big decision point. So,
you didn't consider Erlang?
We sort of did, but because we had heard AWS is all written in Erlang and stuff.
So go back one slide before you chose.
Yeah.
So yeah, go ahead. What was the Erlang part of that picture?
I mean, Erlang decision was, it came up. We didn't do much. But we didn't dig into it too much. I mean, we wanted to use something that our team had some experience in, or So back when we chose Go, it wasn't even Go 1 yet. So it was a pretty risky decision. There wasn't a big community. There wasn't a lot of open source libraries. There was no success stories that I could think of. And we weren't sure if we could get talent. That was another big factor. We were one of the first companies to publicly say we were using it in production, and the first people to post a Go job posting on the Go Nuts mailing list. That was the response, but we did it anyway. So I wrote a blog. I wrote a blog post about this, and it was on Hacker News, and a bunch of people asked the same questions: why do you use this language? Why do you use that? So why not Python? Various reasons. Not as fast, not compiled, so it's more error prone. The indentation-based coding, not a big fan of. I feel like it wasn't a big enough step forward. And if you look at benchmarks, this is Go versus Python on the benchmarks game site. I don't know if you guys have seen this. But for more than half the test, Go is 30 times faster. So, and less memory. Why not Node? There's one word response for this. That's about all you need to know. So, even though JavaScript V8 is actually very fast, surprisingly. Well, not surprisingly, but in some cases it beats Go, and it's not too far off in most of them.
It's because it's the C.
But it's still JavaScript. It's in C. Yeah. So why not Java? Derivative, I already sort of answered this. I wrote Java for a long time, and I just didn't want to go back into it after using newer languages like Ruby and whatnot. And Go is a lot more interesting and exciting, even though Java is still faster than Go. This is the Go versus Java benchmark. Java beats it in most cases, but not by too much. And the memory consumption in Go is much better than Java. Probably because no JVM, no. Why not Ruby? Some people say, why don't you just optimize Ruby? Don't use Rails. That would have been a really smart decision, actually, but it just wasn't enough. The performance of Ruby it's on the worst end of the scale. This is Go versus Ruby. This first line here is 186 times faster on that test. And as you can see, orders of magnitudes faster and a lot less memory. So we wanted a big jump, a big gain, and something exciting to go with it. So after switching to Go, this is as soon as we rolled it out, basically rewrote our API servers in Go, following the exact same API and whatnot. And we reduced our server count from 30 to 2, like the same day. Second one was purely just for redundancy. We're barely using the servers. And we never had a colossal CF again, ever. Oh, no. How do you like that? So performance has been, I'll just hold it. Performance has been stellar. We've never had performance issues on our API servers. We've never had to, really dig deep into Go to optimize it for anything. We still, to this day, run 2 to 4 servers-ish for our APIs. Run a lot more for our background processing and whatnot, but and these servers can handle up to 300 million requests a day we've hit. Bottleneck's always been something else, database or other services we rely on. Memory, there's no virtual machine, so Go starts really fast and small, which I'm sure a lot of you are aware of. Our flagship product, IronMQ, starts up in 6.5 megs, and that includes making all the connections, setting everything up, and it starts up almost instantly. And 2 years in, we've never had a memory leak or problems related to memory. And we're not talking huge machines here. Concurrency, again, I'll bring this up, core part of the language. The high-level constructs, like Go routines and channels for communicating between the Go routines, are just killer, as I'm sure you all know. And Go routines, they're kind of the mix between threads and non-blocking I/O, so you get the best of node-type stuff as well as the threading in Java. And no callbacks, another reference to JavaScript. Reliability, this is a bit hard to quantify, but I feel like everything else we write, if we write it in Ruby and other things, they're always a little bit scared to press the deploy button, things like that. But with our Go applications, they're always pretty confident that it's going to work basically, if it compiles, you feel pretty confident that it's going to work. But you don't feel that way. You get scared to edit a dynamic language code. You push it out, you get runtime errors. We rarely ever have issues after we roll out our Go code. And the code tends to be a lot cleaner and higher quality because the strict compiler is nice, Go format's nice. The compiler where you can't have extra variables that you're not using, it forces you to remove them. And you can do a lot with a small amount of code. I think all these things lead to better reliability. Deployment, since Go compiles into a single static binary, deployment is simple as throwing that on a server and starting it up. No dependencies, you don't have to worry about dependencies being upgraded behind the scenes or anything like that. And for us, the InMQ binary is only 6 megs total. Rolling back, just as easy. Stop the one you're running and start up the previous one. You don't have to worry about, again, dependencies being upgraded behind your back or anything like that. Talent, this one's an interesting one. When we first started a couple of years ago, there was I don't know if anybody had been using Go in production, so it was more people who just wanted to learn. But even after we posted our first job postings, we started getting people, PhDs from top tech companies, even people from Google working on the AdWords team just wanted to work with us just so they could work on Go. So if you're ever considering it for that purpose, you can find talent easily. So anyway, in conclusion, we took a risk, it paid off. You guys are all here because you also believe the same thing. We love the language, love this back. There's a lot of other companies using it now. I'm sure, I don't know how many people in this room are using it now. Hands up for who's using it in production. Yeah, I mean, that's night and day compared to a couple years ago. Yeah, so a couple of final quotes I'll leave you with. This is Rob Pike back in the early days of Go. We realized that the kind of software we build at Google is not always served well by the languages we had available. Robert, Ken, and myself decided to make a language that would be good for writing the kinds of programs we write at Google. And I'm sure that's what we're all writing now, cloud-based APIs and applications, perfect for that kind of stuff. Derek Collison of Apsera. Who's the Apsera guy? Cool. This is one of his quotes from Wired. The management layers and infrastructure layers of the newer technologies that provide this cloud delivery model. Within 2 years, a majority will be written in Go. And we're seeing this more and more. We're in a heavy bit, which is a cloud startup sort of incubator type office where there's a bunch of cloud service providers. And more and more of these people are using Go to write their APIs and do high performance computing. Google Docs fail, or Chromebook, I don't know which one. Anyway, so thank you for listening. That was the presentation. Feel free to email me if you have any questions, anything like that, and I'll take questions right now too. Anybody have any questions? Yeah?
What do you not like?
About Go?
About Go?
That's a good question. It's not necessarily I don't like it, but I find this isn't really a dislike. There's some things like in things like Ruby that are a lot easier. I find myself still scripting a lot in Ruby, stuff that doesn't need to be high performance. I'll still use a language like Ruby because I find you can do it quite a bit faster. But if anything for high performance, just go. Yeah.
How big are your heaps and GC pauses after you launch it? Oh, wow.
I don't have that information handy, but like I said, it's never we've never had to optimize that kind of stuff. So.
What are the instance sizes that you're running on? You said they weren't big boxes, but give me a ballpark.
Those would be EC2 largest for the most part. Anybody else? Yeah.
So I mean, my impression of the Ruby community tends to focus a lot on testing. How have you approached automated testing and unit testing for your Go?
So, I mean, we use GoTest, but we also, going back to the Ruby thing, we have a lot of tests written in Ruby that test our APIs. So, and we wrote a thing called ABT, always be tested, and it's actually a thing that just kind of constantly runs, hits our staging and production environments, runs like the full test suite all the time kind of thing. And that's our Ruby test suite, which hits every API endpoint and does stuff like that. Anybody else? Cool.
Cool.
Thank you.
All right, hey everyone, my name is Quinn Slack, and I am working on Sourcegraph with Biong, who's in the audience. Just show of hands, who has heard of Sourcegraph so far? Okay, a few people. We have a long way to go. We're really new, but we're trying to make something super useful for all of you, and I want to talk about how we're building it, and then do some demos and show off a cool tool we just made for all of you personally tonight. So, quick background. Sourcegraph is semantic code search. So we go and semantically analyze Go code and some other languages. You can search for any function on GitHub or Bitbucket. We can show you usage examples and docs and so on, and see who uses your code. So check it out, but I'll go into some of the details of why we wanted to do this. So the Go philosophy is great. It's like if you follow a few of these conventions that Go set out in the very beginning, you get so much for free. You get code formatter, doc generator, build tool, test tool, godoc.org, all of these things. And it's just if you agree to follow a few conventions. JavaScript doesn't have that. Scala doesn't have it. Java doesn't have it. But Go does. So you have these amazing tools that are coming out. And so our insight was, what more could we do for Go, given that people have adopted these conventions? And can we do the same thing for other languages? Give people the same, amazing tool sets if they just follow a few conventions? And we're a few months into it. We're trying to make programming better in a bunch of different languages, but it's very early. So let me show you what we've done so far. So basically, we want to semantically analyze all the code and index it. So the first thing is start off with a single package in Go. It's actually super easy. There's this Go types package. How many of you have used Go types? Okay, not that many. So another thing that's amazing about Go is it comes with a built-in type checking library. Other languages don't have that. You have to really rip apart the compiler and make it spit out information that it was using just to generate bytecode. So what we do is we go through all the code on GitHub you guys already have, and we will iterate through the scopes after semantically analyzing it. We'll go through all the idents and the AST and just resolve each one of them to a URI. So every function, every local variable that all of you have written, we've probably given it some unique identifier in our system. So that's step one. And the next thing is we store all of this just in a database. We use Postgres, obviously you could use anything. And we go through, and then every single of your Go code files, every single character range, we have resolved to whatever symbol it refers to. So you're calling a function, and we say from position 73 to 75, you're pointing to the HTTP handle. That's what we've done. And then one of the tools that I'll be showing off in just a second is a tool that shows you for any interface in Go all of the types that implement it, even in other repositories, even on GitHub, Google Code, and the reverse as well. So we also go through and all of these interfaces, all the types you guys have on GitHub, we store this triple of info, and then we use that to query and find out who implements a given type. So, do all that analysis, put it into Postgres, and do that for all the Go repositories out there. We have something like 30,000 so far. We're not there yet, all the way. And then we've done it for a bunch of other languages too. But that's the basic idea. And this guy Dimitri came up and talked about Go Oracle. It's a similar idea. We actually use Go types, which Go Oracle is based on. We're just doing this on a larger scale. How can we bring it to more people and make it automatic? So I'll show you what it looks like. So we just want to see, this HTTP handle function. Probably all of you have used it. What is the docs, and then how is it actually used in other repositories? So let me make this bigger. Because we've gone through and indexed all of GitHub, we can find all of these examples from other projects and just let you see, how is this actually being used in real life? And it's annotated like that. So it's a good way to find out how to use code. You can find out who uses your code, because we've gone through and said, this person wrote this function. So you can go to your profile page, it's just sourcegraph.com/your GitHub username, and you can see all these cool stats, show off. And then this is the tool that we built just for all of you tonight. Take any interface, take any type, and find out everything that implements that interface or all the interfaces that type implements. So here's response writer, which is how you return an HTTP response. Scroll down, and we have these implemented by 18 Go types and implements 2 Go interfaces. So if you ever wondered, how do I use this interface? There's no explicit source code connection in Go. That's part of the beauty of Go. But if you need to know that, then you can go to Sourcegraph and check it out. And the reverse of that is, given a type, what interfaces does it implement? We can do that too. Oh, and we've shown off the most popular methods essentially there. So the crypto TLS con type implements all these interfaces. And that's just using the technique that I showed just a few minutes ago. So that's what we have. You can go around and hope this tool is useful. Spread it around and send us feedback. Any questions? Yeah?
What other languages?
We have JS, Python, and Ruby. And we have Java in our back pocket. Not released yet. Yep.
Do you have any plans to allow people to get their proprietary code sort of, introspected in a similar way?
Yeah. Yeah, we do that internally, and that's how we want to make money eventually. I showed steps 1 through 3, and 4 was profit, but we're not there yet. But if you are interested, then come talk to us.
Yep. I guess I wasn't sure. Are you guys written in Go too?
Yeah, we're written in Go.
Okay.
Those are the actual types we use.
Yeah.
I mean, we use Go because we have a lot of back-end jobs that we need to run, a lot of shelling out to Python and so on, and it's really good. Also, Go is the inspiration for Sourcegraph.
So can you talk about a little bit more about the differences, the challenges that you came through implementing for other languages?
Yeah. So
you sort of wish the other languages had maybe the types package.
I wish that other languages had a Python/types package. We use whatever the best tools exist already for the languages we support. We're not going to write our own parser and compiler and stuff. So you might have seen this thing PySonar. It was released recently. We use that. For Ruby, we ripped apart Yard, the doc generator, and it's a type inference there. And for JavaScript, we use Marine Haberbeck's turn package. But then there are a ton of edge cases to handle and versioning, dependencies, and so on. But we have some things that we'll announce soon. We have a pretty cool hire. We want to push forward the state-of-the-art of type inference so that we can do this really well. We can not only index the code and let you browse it, but also do static analysis to find security issues, potential conflicts, and so on. So we want to push this forward. Any other questions? All right.